Hey folks, I think we're live, fingers crossed. Welcome back to another Saturday stream here on the Game of Knowing. This is our third stream. Hard to believe we've already done two of these before, and hopefully this third one will go as well as the previous ones. I'm just gonna wait a moment for people to kind of show up in the chat. I'll probably post about it on Twitter real quick too. This time I've added a bit to the setup, as you can probably see. If I switch over to my desk, I actually got a new webcam. I was using a Logitech C920 for my face, and I got a second one for the desk, which is great because it has autofocus, whereas before we were using a GoPro that's basically just focus to infinity and that's it. So you can see we have some really nice focus here on our little M0 board that we've been using for the past couple of weeks for our baby noodle feet project. We're going to keep developing that this week. But yeah, so we're ready to go. I also have my laptop over to the side this time so I can be checking in on the chat and actually be seeing what I'm doing as well, which is kind of helpful. So real quick, I'm just going to check our audio actually on that to make sure that I'm talking at a reasonable level. Let's see, does this sound good or half decent? Ooh, I think I'm actually going to bring it up a little bit. All right, and that sounded much better. Fantastic. So, if you're joining us now, welcome to the stream. And then real quick, I'm just going to throw our link in Twitter. This is fantastic. All right, so just tweeted about it. Hopefully we'll have a few people with us in just a moment. But for today, let's just sort of talk about what this whole stream's about. So last week and the past couple of weeks, we worked on building this little board, assembling it, which is kind of a brain board for Sarah Petkas's Noodle Spawnling project, which is a mini version of her larger Noodle Feet robot. And so you can see sort of the canon version over here. This is one I built a little while ago with Sarah's official brain board that she designed, which is called the Marshmallow board. So she released the 3D files. I 3D printed and assembled this, and then added in the brain board. His name is Rigatoni, and he's just a cute little robot that sits around, makes some beeping noises, blinks at us, and just sort of hangs out. But super cute, and designed to be like its bigger brother, the real Noodle Feet, sort of a robot that causes us to question the ways that we think about robots and machines and the ways they interact with their environment. So whereas more of sort of the traditional robot you might think about, something like the Curiosity rover or other robots are very sort of precise and numerical in the things that they do. They accomplish very objective tasks. Noodle Feet and the Noodle Spawnlings are all about touching and tasting and more about feeling and emotional exploration, which is kind of exciting. So we're working on a DIY version of this brain board to put into Rigatoni's sibling. One sec, let me just kind of get him situated over there again so he doesn't fall over. right here. So in the last stream, we built this little skeleton for the next one, and we've also built this DIY brain board, which does, our goal is to make it do pretty similar things to what the original Marshmallow does. This is actually running an ARM M0 processor. It's an Adafruit Trinket M0. So we have a little battery board down here. Then we have two eyes that can blink and wink and those sort of things. We have a little piezo element so he can speak. He'll have a little bit of a voice, and we can compose some things for him to say, some little tunes. It's going to be cute. And then also kind of the biggest addition beyond what the Marshmallow board does is this right here. It looks like a capacitor, but it's actually a little vibration sensor. It's like a metal can package, and then there's a little spring on the inside. So when you flick it, or it's gets shaken or whatever, the spring makes contact with the sides of that metal can, closing the circuit, and we can sense that so that maybe this baby Noodle Feet can say something or protest or do a special eye animation or something like that whenever he's moved. That should be kind of cute, just making it more interactive. And then also something we didn't add, but it's just part of the board and we might want to do something with. Not totally sure yet, but there's a little dot star addressable RGB LED there in the middle right next to the M0 chip. So we can use that for some gentle lighting and other things like that that might help to sort of communicate mood. I don't have quite as concrete plans for that, but it's kind of a fun peripheral to have just in case, if you will. So we now have 3 people viewing. Hello to everybody in the stream. Thanks for joining me today. If you're working on something, I know I always love to watch streams and work on projects on my own, so if you're working on something, let me know what you're doing today. And if not, that's cool too. I'm glad we're just hanging out. So as you can see, our hardware side is largely done. We have our skeleton done. We have the brain board physically done. We did have some issues with battery power, and so this week I actually picked up this, which is a battery holder for a 2032 battery. We actually have the battery holder we have right now is just for a little 12 millimeter battery, which I don't think can supply as much current. They're both 3-volt batteries, but I think this can supply more current, and I'm not 100% sure on that, but I'm going to try swapping these out because the 12 millimeter battery, forget the part number on that, but just wasn't giving us enough juice to power this board. So we'll try it out. We'll get this running on USB power and figure out some behaviors that we can add. And then maybe at the end of the stream, assuming that all that works out, then we can try out this battery. If this doesn't work, we might have to switch to a lithium polymer or something else, which adds a lot of size and complexity, especially for charging, but it might be necessary. But the bulk of this stream is just going to be coding this board and trying to get some neat behaviors that will give our DIY baby Noodle Feet a little bit of personality, a little bit of a voice, and some interaction for that vibration sensor again. So with that being said, let's switch over to our computer screen. Sorry about the kind of tunnel effect there, and we'll switch over to our CircuitPython text editor. So the way that CircuitPython works, which is pretty neat, is that the files, like the text files for your code, are actually stored on the board themselves. So let me just make sure that we have, yeah, okay. So I'm just going to plug in, might as well just bring this full screen actually, or a little smaller, I guess, because you have the chat covering part of the screen. So I'm just going to plug in the Trinket M0 here. So you may be able to hear a little tone, sort of an ascending tone, and that's actually what we programmed last time. We figured out how to use some of the PWM functions on the M0 with CircuitPython to play some little tones. So I'm not sure if you can hear it, but it's just like a little ascending and descending tone. So today we'll be playing around with that a little bit more to actually get something hopefully a little bit more interesting. So I'm going to load up the Python code off the board. As you can see, it's stored here in this code.main. It's pretty cool. It's really great because then you don't have to worry about, oh, do I have this code stored on this computer or that computer, or did I make sure to upload it to GitHub or anything like that. It's just always on the board. So you can bring the project with you wherever you go and use a text editor to write your CircuitPython. Awesome. Just trying to get this window positioned so that you can see as much as possible. All right. So real quick, I'm just going to comment out that little loop where we have those tones playing, just so we don't have a bunch of noise going the whole time, and then we can add more back. We can add some sound back in a minute. So I'm just going to save the file, and there you go. That's all there is to it. So now you can see on the screen down here, it's saying the loop because I have a little print statement here, but nothing's happening in terms of sound. We can also set the red, green, and blue values of the dot star really simply here. Let me just take you through the code real quick in case you weren't watching last week's stream. So here we import our libraries and those sort of things. Here we establish the dot star. And so the way that works is you kind of declare like a strand of dot stars, because normally you're not just going to be using one. You'd be using like a strip or even like a full display out of dot stars, like a matrix. We have the brightness set real low because that's all you need. I mean, as you can see that blue light glowing in the middle of the board pretty clearly. If it was any brighter, it'd start to sort of lose the color, kind of starts to blow out even when you're just looking at it with your eyes. We declare the pin as an output, and that's just this pin 13 is just the onboard LED that we can use to blink. Right eye is Noodle's right eye, so that's right here, this little guy. And then left eye is over on the other side. We have that so that we can do not only blinking, like both eyes at once, but also winking or directional blinking, which is where like you blink one eye and then the other. And I can show you the code for that in just a moment. The piezo, we declare the piezo as a PWM out. Had a little bit of confusion with that last time, but luckily it's all cleared up, as you heard just a moment ago. Okay, yeah, and then right eye and left eye, we're declaring those. And then also, we declared the sensor. That's the little vibration sensor that I showed you a moment ago. We declared that as an input, and we have a pull up on there so that when it's bridged to ground, when the switch is closed, when it vibrates, hopefully we'll be able to detect that. We've written a little moved function here, which doesn't really do much of anything right now, but eventually we'll put in the code that would run when our baby noodle feet is moved, or that vibration sensor is triggered. We have eye behavior. So this is a lot of what we worked on last time, and this is the behaviors that are everything related to the eye. So and there's like a number assigned to each one. So the first one is the blink. So both of them go off and we wait and they go back on. The second one is the right wink. So just the right LED goes off and then back on. Then the left one winks. And then these two are like those directional blinks I was talking about a moment ago. And we played around with those timings a little bit, and I can show you those in a moment. Here, why don't we actually just do that right now? As to what those look like. So I'm just going to uncomment this code that we wrote last time, just so we're all kind of on the same page as we start the stream as to what this thing actually does. All right, so I'm going to save this. Okay, so let me just kind of rotate this a little bit so that you can actually see what's going on. Hopefully. Okay, so again, like down in like the bottom right-hand corner of your screen, you should be able to see the desk cam. So there's the one wink. There's the other wink. There's one of the directional blinks. There's the other directional blink. And then there was the both eye blink at the same time. So those are our little eye behaviors, and those will be randomized. We might also add some other thing for, again, as I mentioned a moment ago, like if it gets moved or bumped, might want to have some special behavior for that. Hi, welcome. So now that we all sort of understand what we have so far, what the code is so far, we can start to move on a little bit. Oh, and then one more time, or one more thing. Here at the very end, you see if sensor.value equals false. CircuitPython does not have interrupts, does not have hardware interrupts, which is kind of a bummer, but it is what it is. And they're not planning to add them. So we're going to have to, for that little vibration sensor, we're going to have to pull it as opposed to having an interrupt that will be triggered by it being pulled low. So hopefully, and this is a pretty fast little microprocessor or microcontroller, so hopefully we'll be able to loop through this quickly enough that we'll catch any vibrations or motion when that sensor is triggered. If not, that could be an issue. But we want to do our best to keep our loop as light as possible so that we're polling as often as possible so that even minor vibrations can be caught. So ideally, we'll have as few of these delays as possible, and then offload as much as we can into functions that will have their own delays and stuff in them so that we're not delaying as much every time we loop through. The one thing we do want to have here in our loop, though, is some sort of a randomizer, right? Because as you may have seen just while you're watching, over here on the left, Baby Noodle Feet with the marshmallow board, every once in a while he blinks or winks or whatever or makes a little sound, but most of the time he's just sitting there, right? So we need to have some way to randomize the behaviors so that every once in a while it'll do something, but it's not just constantly doing every behavior that it has. So over on my laptop to my side here, I have a little CircuitPython reference because this is new to me. But we're going to use, let's see, we'll create a variable called randomizer, or we'll just call it random equals random.randint. So this randint function, there's a great little tooltip here in this Moo editor, but we're just going to go between 0 and 100. So that's going to give us a random number between 0 and 100 inclusive. And then, let's see, we probably want, so this is something we're going to have to play around with a little bit, how frequently we want behaviors to happen. But let's see, maybe once every 10 loops we want something to happen. We can start out with that. So actually, we want it to be a lot less than every 10 loops. So because, again, we want this loop to be running as quickly as possible. So let's change this to, yeah, let's go to up to 1,000. And that gives us a little bit more resolution. So now we can say maybe if rand_num is greater than, let's say, 950, or maybe even 975. So only if this random number that we create is larger than 975 are we actually going to do anything at all. So then, on the marshmallow board, and this is something that I think I want to keep, Noodle, whenever Noodle makes a sound, he does some eye action, but he does not always make a sound whenever he does not always make a sound whenever he does an eye action. So always an eye action, sometimes a sound, pretty much. So let's say within this, if rand_num modulus 10 equals 6, And this might end up being too infrequently, that it's going to or random modulus 10 equals 7. Okay. Then we're going to do the sound. Yes, thank you. Thank you very much. Yeah, I'm not sure if Sarah knows about this stream, but I think she's seen a couple of the previous ones. It's kind of neat to have a bit of a dialogue with her on Twitter and stuff about the project, because as I'm sure you've seen, she's actually continuing to develop the baby noodle feet with like some vibration motors in the feet so that it can actually kind of move around, which I'm pretty excited about. So yeah, I think she's aware. I don't know if she's watching right now, probably not, but she knows that I'm working on this a little bit, which is cool. Have you built one, Peter? I hope I'm saying your name right. Is it Peter? If not, you totally should, because I think you'd enjoy it. It's pretty simple to make. Okay, so if random number is greater than 975, we'll do some action. If random number modulus 10 is 6, let's see. Yes, that's correct. Awesome. Been having pretty good luck with that lately. But I always want to check to make sure I'm not horribly butchering someone's name. Okay, so if random number modulus 10 is 6 or 7, then we're going to make a sound and blink. So I guess we'll do the sound first. Peter says, if she adds vibe motors to the feet, Micah can make it into a random drawing. Micah can make it into a random drawing noodle feet too. Yes, Micah, that vibration motor thing is so cool. I'm not even totally sure how it works. Like that's kind of beyond my magic. But if you're watching and you're not sure what we're talking about right now, Micah Scott is another awesome YouTuber who inspired Sarah to do the vibration motor feet that sort of moves around. She's been working on this really cool project where she has like a really minimalist robot that's controlled by 3 vibration motors, and it draws on a drawing tablet. And then, so she inputs an image, and then based on the feedback from the drawing tablet of, where the thing is actually, where the robot is on the tablet, she's trying to develop a program to control the robot through those 3 vibration motors to enable it to steer around and sort of draw whatever image she inputs. However, because it's just vibration motors, obviously there's not very close control between the direction she knows she needs to go and the direction that the robot actually goes. So it's sort of an interesting art project because there's a lot of entropy in the system. Yeah, it is kind of fun to build stuff that dovetails into other projects. It was neat to see Micah and Sarah sort of working on those things at the same time. And then Sarah's doing a similar version, but without like the feedback loop. So she's just going to have that baby noodle feet. She's just going to have that baby noodle feet draw all over, and it's going to be super cute. It's going to be awesome. So for us here though, also trying to dovetail into some other projects, we have, okay, so here we're going to make a sound. So I think I want 3. So I'm going to create another function for all of our sound stuff. So definition, squeak. And then we're also going to have this one's going to be called S number, so that we're going to have a few different sounds so it doesn't become overly like repetitive and annoying. So S number will be able to indicate which one we want. And I think I'm going to have S number int between 0 and 3 inclusive. So we'll have 4 sounds, 3 for normal behavior, and then 1 sound for if the vibration sensor gets triggered. So kind of a special event sound, if you will. So if we're in this range, we are going to be making a sound, so we're going to actually create another random number. So s rand num for sound random number or squeak random number. And this is going to be equal to random.rand int 0 to 3 inclusive again. So now we can do squeak s rand num, and this randomizes, or at least pseudo randomizes, the sound that will be produced. Next, we can do, I think I'm going to do, I guess we can just do this again. This code is not elegant, but it's hopefully going to work. And that's what we're going for with this. So I'm going to create brand num. If I was smart, I would just reuse the same random number we used previously, but it's all good. So brand num equals random.rand int between 0 and, let's see, we have, this goes up to 4. We have 5 different I motions. So 0 to 4. Cool. And then we're going to call I behavior with an argument of brandnum. So I brandnum. All right, so a few superfluous variables here, but we're running a pretty powerful chip here. It's an M0. We can handle it. Cool. So that's our sort of, we've now created an if statement that will only be triggered if we want to have an action, and it will only do that 1/4 of 1/10 of a percent, so like 2.5% of the time, and then only 2/10, or I guess really 2/9, no, 2/10. So only 20% of that time, so only 20% of 2.5% of the time will it make a sound. So 0.05% of the time it's going to make a sound and blink. Otherwise, we're not going to make a sound, we're just going to blink. So we can just copy and paste this little piece down to here. This might cause an issue because we've declared this variable twice, so I'm just going to declare it up here. I haven't used CircuitPython very much before, so I'm sort of just being a little bit extra careful. So int brand num. Cool. Awesome. So now we have our little randomizer. And the nice thing is, when this isn't triggered, when we're not going to do an action, this doesn't take very much time at all. There's no delays or sleeps in this, which is good, again, for our polling thing down here. That means that we're going to be polling more often. The issue, of course, is that when we are in the middle of another action, so let's say that this does trigger and we need to make a sound and blink, then while that's going on, up here we do have a lot of sleeps and those sort of things. So while we are in the middle of a random action, we won't be able to detect motion, which is probably okay for this, but in a more, scientific robot, something that needs to work consistently, we wouldn't want to have that. We'd want to be using an interrupt. However, as we discussed before, this is not a super scientific robot. This is a robot that has feelings and wants to explore and view the world on its own terms. So I think that if sometimes he doesn't want to respond to vibration, that's okay. That's okay with me, and I hope that it's okay with you as well. So with that randomizer implemented, we can now, I think I'm just going to comment out this little iMotion test code for now because we want to be able to isolate bugs later on, and this is kind of a useful thing to have. So I'm just going to comment this all out. Nico just commented, on what are you programming? Okay, so it's a really good question. So I'm using what is essentially a text editor called Moo on my Windows computer, which is an editor that I'm using for CircuitPython, which is a language created by Adafruit based on MicroPython, which is basically a version of Python specifically designed for microcontrollers. And then over here in the little display on the bottom right of your screen, you can see this is actually the microcontroller that I'm implementing the code on, and that the code is actually saved on. It's a little Trinket M0 board from Adafruit, which has a little M0 processor on there, a little dot star on there, and then I've added on a couple of LEDs, a piezo, and a little vibration sensor. So that's sort of the platform we're working on. And the project overall is a brain for this little guy, little robot, called Baby Noodle Feet, which is a project started by Sarah Petkus that I'm sort of remixing a little bit, you might say. And welcome to the stream, Nico. Oh, sorry for bumping the camera. Cool. Okay, we're still in focus. Can still see what we're doing. Hopefully. One sec. Let me just adjust the view there. Okay. Hopefully you can now see that M0 a little bit better. I apologize again for that tunnel effect when I show you the OBS screen. So I'm just going to get our little test code kind of out of the way here. We can bring that back up into the program later if we need it, but for right now it's kind of cluttering up the loop. Down here we have the code that we tested out last time and that you heard a minute ago that plays a series of tones. So for F in this list of frequencies, piezo.frequency equals F, so we set the PWM frequency to whatever it's on in this list, and then piezo.duty cycle, this sets the duty cycle to 50%, which is what we want. Then it waits for a quarter of a second while the tone plays for a quarter of a second. Then it sets the duty cycle to 0, which means that even though the frequency is still set for that timer in hardware, the duty cycle is 0%, so it never goes high, which means you're not going to hear a sound. Then it's going to wait for 0.2 seconds, and then it loops back up and plays the next tone. So that's sort of how this works. However, for our application, we don't just want to have a looping list of a whole bunch of different tones. We want to have some more interesting things. So we are going to create, we already did create this function up here, which is going to have 3 different squeaks, which is kind of fun. So we can just create a few different ones. So if squeak, if S number is 0, and again, this is going to range between 0 and 3 inclusive. So I guess I shouldn't really say it between, but whatever. Else if 1, else if S number. Been writing a lot more. Oh, yes. Thank you for letting me know, David. I don't want to have this hard to read for you. Okay. Let me just wait a moment while that propagates to the stream that I can see on my other computer. David, thank you for letting me know. Bring it back a little bit. Hopefully that's okay, and I'll keep an eye on it. Awesome. Yeah, I hate that when you can't see the, you can't actually see what the person's working on. Okay. little bit more. Okay. Yeah, no problem. Thank you for letting me know. S, not sumber, S number. Then we just need to add a couple more lines of this. Else if S number is 3. Perfect. Love this clicky keyboard because you can really hear what I'm doing. I just got a new mechanical keyboard with blue switches in it, and it annoys the hell out of my roommate, but it's a lot of fun. I think he just got one too, so you can have a little bit of keyboard auditory warfare. Cool. So here we want 4 different behaviors. In behavior number 3, this one is going to be earmarked for vibration event. So only when we sense a vibration are we going to do this third sound. So I think that what we can do is, any little ditty that we write here is going to be essentially just a sequence of tones, right? So they won't be in clearly ascending order like they are in this little example that we have, but it'll be a sequence of tones, probably with different timing. But we can more or less copy pasta this code up into here and then use that as a basis and then just rewrite this sequence of frequencies for whatever different little song we want to play for each event. Now, just as a bit of a disclaimer, I am not terribly musically inclined, so this is going to be a little bit of trial and error, but hopefully it'll be fun. All right, so we now have sort of a blank slate to write a series of frequencies. Make sure. That's the thing with Python, man, is you got to be real careful. Oh no. About your indenting, and I have kind of messed up a little bit here. Hopefully this is. Yeah, okay, there we go. Now we're aligned correctly. Using tabs, which is helpful, saves a lot of time, but can still run into some pitfalls. So we'll just uncomment these as we go along and write each one. So I think that for the very first one, I'm going to sort of replicate what I already know works and what we can hear on the marshmallow board. I'm not sure if you can totally hear those, but it's just like a little sequence of 3 notes, very quickly ascending. Kind of sounds like a notification you might have gotten on your phone in the early 2000s. So we're going to speed this up. First of all, we don't need 1/4 of a second between sounds, so I'll go 0.1 as a delay. Again, we're just starting out experimenting here, so we'll see. Then this is going to be 0.05, because we want to have very little delay actually between tones. Might actually decrease this down to 0, I'm not sure. And then I want it to be relatively high, so I'm going to delete these lower ones. And so the idea here is that we'll have 440 hertz, 494 hertz, and 523 hertz. I'm not sure if that's actually the frequency. It's probably, this is more likely in the thousands, but whatever, we'll go with it for right now. This may not be indexed. This may not even really be indexed to actual frequencies. Nico just commented, maybe a problem with the refresh rate of the window capture. Yeah. Are you seeing real low frame rate on the display? Okay, well, hopefully it won't get too bad. We do have, essentially 3 1080p streams. Nico comments. The mouse is okay, but we can't see when you are typing. Oh, that's weird. So the frame rate is okay. Yeah, camera's okay. That's a really weird problem. I would almost expect it to be harder for it to capture the mouse than the keyboard, because this moves around much quicker. But I assume that you can actually see what has been typed once it has been typed, hopefully. And I'm not moving around the window too much, so yeah. But thank you for letting me know. These are things I'll look into before the next stream. So cool. So we now have our first sound effect sort of set up. I'm going to scroll down and put into our loop something to test that out. So that is squeak with an argument of 0. Squeak. Cool. While 1 delay, or not delay, time.sleep. We'll have this go for 1 second. So it's just going to loop forever, doing that little thing that we just wrote once every second. So we'll save. Oh, okay, so we have a syntax error in line 60. 60. Just says invalid syntax. Piezo.free. Oh, okay. We need to just tab over. One of my favorite kind of bugs, the ones you can just see right there. Save. Okay, invalid syntax on line 65. All right. Oh, okay, yeah, I had the same problem last time. Keep writing else if, it's just elif. Elif. I think that's, I really don't like that as a contraction, but whatever. Line 72. We're getting somewhere. Elif. S number is 2. Not seeing much of a difference between that and other. This might be an indentation problem again. In fact, I think that's most likely what it is. Hopefully, we'll see. Otherwise, we'll be fixing a problem that just hasn't arisen yet, but will eventually arise. Getting rid of these hashtags. All right, we'll save that just to see if that was in fact the problem we were running into. Yeah, okay, so now we've kicked the problem on down to line 87. I think we did fix whatever was wrong there. I'm not sure if it was actually indentation or something else that we just kind of fixed accidentally in the process, but whatever it is, we're now compiling down to line 87, or interpreting down to line 87. Don't want the Python gods to attack me here. So line 87, while true. Yeah, line 87 is good. So now down to line 92. Indentation. Line 97. Okay, so it's not liking this. I think what I need to do is declare this BRAN number, or is actually define it. So I'm just going to do this. This is more efficient anyway. I'm going to do this up here. Okay. So that we're not replicating that code essentially. So we'll save that. Now down to line 98 we have a problem. If random number nope. Oh, there we go. I always forget those little, not binary, but just logical comparison symbols for Python. So I'm not sure if you can hear that, but it is now making a sound. I'm going to bring it up next to the microphone, just so I can be totally sure you guys are hearing what I'm hearing. So here's the very cute little three-tone thing. It is still a little bit too slow. It's cute. I might actually, use something like that for another sound, but it's not quite what I'm looking for. I think I want it to be a little bit higher pitched, and I also want it to be just quicker. So it's not so much three distinct tones, it's just like a little ascending sequence, if that makes sense. Let me just check on, yeah, okay, so I just wanted to make sure that I put that microcontroller board back in the frame. It's looking good. So I'm going to, actually, this time is okay. It's really this. I don't think I want any delay. In between the notes. So we're going to save this again. Okay, so that's better. Kind of. In terms of timing, it's better. In terms of frequency, hopefully you can hear that when it's up there. In terms of frequency, I think it's too low. And it actually sounded better for this lower frequency when there was a little bit of delay between them. So I think what I'm going to do here is increase these. So we seem to have so I think this is a scale. So I think what I'm going to do is maybe just double these. That'll be 988, right? And this will be 1046. 46. Save that. Oh, that's good. Okay, we got it. This is very cute. Okay. I like this a lot. Love that little tone. It almost sounds like a tone it almost sounds like a sound you might get in like a video game when you like level up or something like that. I'm going to decrease this time a little bit, maybe 0.075. I don't know if we have that much resolution. Okay, I'm going to try 0.05. Nope, 0.75. Or let's try 0.08. I think that's it. Tell me what you think in chat when you hear this. I think that's pretty good. It's cute, it's hopeful, it's quick. And it maintains kind of a musical quality. It's not overly electronic. I mean, it is pretty electronic by nature, but I think it's pretty good. Let me know what you think, because if you guys don't like it, we can tweak it a little bit more. I'm sure you know more about this than I do, if you have any other ideas. So there's like a little ascending one. This is a pretty happy robot, so I don't really think we need like a sad sound. I might just try one out though, like get like a kind of descending sound. So that could be maybe like 3 notes in the middle here that are like descending. So I'll just invert the order. And again, we'll play around with this. Okay. I'll just switch the 440 and 349 here. Okay, so, and then down in our loop, we'll change the thing we're testing to S to squeak number 1 and save that. This is a little sad, a little funny, but a little sad. Okay, so you can hear that, hopefully. Even if you don't have any like thoughts on the matter, if you could just like let me know how the audio level is for that, just like to make sure you can actually hear what I'm telling you about right now, because otherwise there's no point. Okay, so I'm gonna decrease this like wait time to like 0.0. Oh, let's go to 0.1. Audio's okay. Awesome. Thanks, Nico. Okay, so 0.1. Again, fade. Yeah, so Nico says, you're right. Maybe you could try like a fade in frequencies. Yeah, let's do it. So yeah, so we'll define, yeah, this little descending thing. If we bring, let me just finish playing around with this real quick, but this one's kind of fun. This has a little bit of attitude to it, but I don't love it. And again, this sound is really to convey like a character, a sense of character. I don't think that sound necessarily does that so much. So let's run with Nico's idea. I really like that. Let's go with a fade. So we will define. Actually, let's keep this one around for now because we have, this is code. We can just add another one. So we'll go with fade frequency equals 1,000. Cool. And then we can go with while fade frequency is greater than 75. So we're going to fade down from 1,000 to 75, and we can try it in the other direction as well. Piezo frequency equals f. Duty cycle is a half. Time.sleep. So we want this to play. We want this to play for like a really short period of time. So we'll go 0.01. piezo duty cycle. We actually don't want this to happen in this case. We just want it to fade down. So we can, I guess I might actually go like 0.2. And then time.sleep, we're going to get rid of this whole latter part because we don't actually have like a pause between notes. It's a continuous fade. So we'll save. We don't want to save quite yet. We're going to change this to, we're going to squeak pattern number 2. So cool, that's what we just wrote. We'll save that. And we threw an error. So line 91 and line 74. Piezo, oh, okay. Just fade frequency. And then we also need to decrement that. I totally forgot what I was doing there. Fade frequency. Cool. And then after this is done, we're going to, I'm going to try just doing this like one at a time. So fade frequency minus 1 minus equals 1. I think that minus equals is implemented in this. I'm not sure. We'll see. Fingers crossed. Okay, this is way too slow, but hilarious. It's just a very slow decrease. Okay, so we can play around with that a little bit. We can also have it like go up and down a little bit. So we're going to go, first of all, we're just going to decrease that to 0.01. We can, yeah, because I would rather have it be like a smoother fade with like less time on each frequency as opposed to skipping frequencies altogether. So let's just see how this sounds when we speed it up. It's going to double the speed. Yeah, still way too slow. Can we add another 0 here? Oh, okay. Listen to this. So it becomes almost like a blaster sound is what I kind of think of that as. This isn't going to work on its own, but maybe we could do like a series of those. Instead of just playing pure tones, we could play a series of faded frequencies over different ranges. That's kind of neat. So I think real quick, I'm just going to increase the time. Nope. That did not work. Okay, so now we have something that sounds a little more like this. Okay, so I like that. I like the period of that. I'm going to raise our floor because like at the end of that faded sound, it's just like one consistent thing. Like I think we sort of hit a bottom value of what this piezo can reproduce. So I'm going to go up to maybe 150. Let's go 200. Nope. I'm going to go to 300. Oh, okay. So we also have another issue. So part of it is that we're hitting like a basement of like the lowest frequency this thing can reproduce. The other thing is that we are leaving the piezo on at that lowest frequency for 1 second, and whatever time it takes for this thing to finish the loop every time. So that's an easy thing to fix. We want to change this so that at the end when this is all done, we do piezo dot frequency, or no, piezo dot duty cycle equals 0. So just that we're leaving the piezo off once we're done controlling it. So we'll save that. Okay, and now we can actually lower that bottom value again. We'll go to 50. Awesome. Take a listen to that. So again, it's not like a sound effect by itself, but it sounds really cool, and I think we can compose something from like several of those. So Nico, thank you very much for your suggestion. So let's see. It could almost be a sound effect by itself, but I want to do a little more. So I tell you what, I'm going to speed this up again. So it sounds like this. Okay. Just bring it up so you can hear. And then we can compose something out of those. Okay. So now we can think of that little boo as one note. And then we can reset fade frequency equals, let's try 2000. And then we can fade that down to maybe 500 or something like that. Or maybe 750. And Nico or anyone else, if you have any other ideas for what we can do with this, let me know. Well, fade frequency is greater than 750. Piezo dot frequency equals fade frequency piezo dot duty cycle equals 65536. Anyone else? 3 people? Yeah. Well, I was actually kind of impressed. Like the last stream, we didn't have too many viewers. I think we had like 35 people overall over the course of the stream. But then afterwards, PT, Phil over at Adafruit saw that we were using CircuitPython for this. So he shared it, and we've gotten like a couple hundred views on the archive stream. So, you know, it's not just the people right here. Hopefully we'll also be able to talk to commenters and those sort of things in the coming week or so. See if people have other suggestions for this. I'm also going to open source all of this code, throw it up on GitHub, so that you could build one of your own or tweak the code or whatever. So keep an eye out for that. So this is not just the dialogue we're having here in the stream. It can be a little bit more ongoing than that. But I really do particularly appreciate the 3 or 4 of you here right now who are watching and checking it out. Fun that we can be kind of working on this together. So duty cycle. I'll just copy and paste this again. Copy. Okay, so I'm going to give us a brief little pause in between the 2 fade notes. Let's call them fade notes. piezo duty cycle 0. And then we're going to time.sleep. We'll give that a 0.1 second delay there. We'll try it out. What? Oh. So it's just now just emitting like a pure tone at that 1000 frequency value. Just forgot to put in the decrement thing. Paste. Save. Oh, okay. So you can hear that now. I wonder how much resolution this time.sleep thing has. I want to give this 0.75 so that we can get closer to the same like length of time for both of these. Zero 0.5. Okay, so I think that the maximum resolution for this time.sleep is 0.001 seconds because I'm not seeing any change below that. So I'm actually going to raise this threshold up to 1000 so that we have, so that these both take the same number of beats, if you will. Okay. So that's what we have now. It's not really very interesting. Minimum 10 to 13 milliseconds. Okay. That's good to know. Thank you. So what I might try doing is changing this around a little bit. So now we're going to be decreasing the frequency at twice the rate. And this is just too fast. It's just not interesting. That sounds more or less like it would if we just played a pure tone for a very short period of time. So I'm going to change that back to 1. And I'm going to try like a little do. So I'm just going to bring this down real quick. And then this as well. Okay. So now this is going to play that lower fade tone, the higher fade tone, and then the lower fade tone again. Okay, and also, I mean, I just remembered that this is actually not going down to 0, this is going only down to 250. So I'm going to raise this up to 1,250. Okay, so here's our sound now. It doesn't have a lot of interest. I think what I'm going to do is we'll go one low, one high, one low, and then one much higher. And again, I don't want these to be like super long. This is just like a quick thing that he'll play randomly. So it needs to be relatively brief. So we can bring this whole bit down. We'll copy that. Paste it here. And delete those. So we'll start at, I'm interested to see how high this goes, but 4,000 to 3,250. Okay, so that sounds very different. Huh. So that's probably starting to approach the upper limits of this piezo, or at least what we can hear with this piezo. So 4,000, I'm going to bring this down to 3,500. And then, again, we're decreasing by 750, or decreasing down to the maximum frequency minus 750. So we'll go down to 2750. Huh. See, when it's repeated like this, it almost becomes sort of rhythmic, but I don't think that in a single go it's very interesting. I'm going to try commenting out the first thing just to see if that improves it at all. You know what? I think that just the middle two are good. Take a listen to this. It's like, it's quick, it's 2 beats, almost like 2 syllables. Yeah, I like that. And then we can use the other tone, we can use these other fade tones for something else. I like this like higher register because it really fundamentally changes the nature of the sound up at like, 3,500 or even 2,750, or when we a moment ago were at doing like 4,000. The piezo sounds very different up at those higher frequencies. So maybe we'll try that in our number one behavior or something like that. Okay, so I'm gonna actually, yeah, let's try those higher ones. Cut these out. Can get rid of this. Nico, thank you for that suggestion, because these really do have a lot more interest than the pure tones did. Cool. There's sort of our template, if you will. So now we have 2 of 4 of these little behaviors created. Oh, I have an error on line 71. I think it's just these comments again. hopefully. Yeah, okay, cool. You could probably change the shape of the frequency, square wave, sine, yes. We are just on the PWM output though. So I'm not sure if we have that capability. I can check the documentation. Another way to do that would be, to add a capacitor or something like that. But I'm trying to keep this very minimalist. We could also play around with the duty cycles a little bit, although I think that will mostly just affect the the volume, really. But I think I do want to stick with these, simpler, somewhat more digital sounding things. I don't want to overcomplicate this. So I think I'd rather stick with, just these simple PWM functions. The other thing to remember is that CircuitPython is not terribly built out right now, and they are keeping it aimed at beginners, really to the exclusion of all else. There's no interrupts, as I mentioned earlier. So we are a little bit limited in terms of what we can do. Many of the features of the very powerful M0 chip that this uses are not available to us through CircuitPython. I'm using this project kind of as an experiment to learn a little bit about the language, understanding in the process that I am giving up some functionality. So I think what I'm going to do is we have this little ascending tone, which I think is cute and fun and perfect, and very reminiscent of the sound that the original Baby Noodle Feet makes with the marshmallow board. It just has one little ascending tone that's similar, not identical, but similar. The piezo element on that is surface mount and has a very different timbre than the one we're using. So this number 0 sort of pays homage to that. Number 1, we'll use that higher register that we discovered a moment ago for this piezo element. Number 2, we just created, is this sort of 2 fade tone thing. And then number 3 is going to be our vibration event. I haven't really decided whether Noodle is going to be happy or a little bit annoyed to be picked up or moved around, because obviously he does like to touch and to feel and to interact, but at the same time he is not, he's very much a free spirit. He's doing his own thing. So I think we can kind of balance that in the sound that we create. And that can also be reflected in maybe the color of the dot star on board. Maybe it goes red when he gets vibrated or something like that. So he's a little bit miffed about the whole situation. But for right now, let's focus on this other random event. Real quickly, this fade noise is beginning to get a little bit grating, so I'm going to comment that out and save. Cool, so no more noise for right now. It's grating when it's playing over and over again right now, but I think that when it's just playing randomly and very infrequently, it won't be quite so bad. Or it won't be bad at all, hopefully. So it'll be playing 1/3 of 0.05% of the loops. So I think that's hopefully infrequently enough. So we're now here. S number is 1. I think that maybe just oscillating very quickly between 2 frequencies a few times, almost like a bell ringing. Like a very small bell, might be kind of cool. So we can, I think I'm going to go up to that 4,000 hertz. It's probably not 4,000 hertz. but whatever. Down to 3,500. Okay. Might also try inverting this, going from 3,500 up to 4,000, because we've just done the decrementing, not incrementing so far. But for right now, we'll just try this out. It's a pretty easy thing to switch in a moment if we want to. And then we can go, just bringing this down. We do want really quickly to turn off the piezo in between notes. We'll go to 0.05 for that. So it's a real quick little delay. And this will be, we can try going even higher. I don't think this is going to be terribly good. I think that they should be a little bit closer together than this, but we'll try. Oh, okay, we haven't told it to do anything, so we want S number to be 1. Cool. Saved. Nope. One second, let me save that real quick. Oh, okay, so we did that same thing again when we forgot to turn off the piezo. Or I did that same thing again where I forgot to turn off that piezo, taking responsibility there. Paste it there. Cool, so that just turns off the piezo afterwards. And then we also want to like kind of oscillate this a few times. So copy that, bring it down. So that goes back up. Now we will do the higher frequency one. Okay, so let's make sure that we have all of the little like delays in here that we need. So first it runs this first one, delays, runs the second one, does not delay in between there, so we want to add in this, copy, cool. Does the third one, does delay here, does the fourth one, and then turns off. So, and again, I turned off the sound down here, so now on line 95 we have an error. Oh, okay. We also do not need this at all, so cool. You can now save that. That's almost kind of car alarmy, and I don't love it. A little bit sassy, but not fantastic. I'm going to try increasing this by 2 and then bringing this up to 3. So this will be a little bit quicker. So what we've just done is we're now decrementing by 2 instead of 1, but we've also extended the time that each note is playing for. And that is horrible. So I'll bring that back down to 0.02. Oh, don't want to be making changes down here. Okay, let's save this. Still way too slow. Okay. I like this. Might play around with the frequency a little bit, but I like this. Do 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 do. Do 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 do. Do 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 do. Okay. That's pretty good. Quick. Cool. So fade frequency. I think I'm going to bring the frequencies down a little bit. So I'm going to go 3500 to 3000. And we can bring that down even more, perhaps. And then 4500 to 4000. And then 3500 to 3000. And 45, 40. Cool. So this will be a little bit lower frequency. Yeah, it sounds more and more like a bird. I like that though, because it's like, you know, it's supposed to be like a baby, right? You're right. It sounds like a little chick cheeping. And we can try a lower frequency where it would sound like a little bit more electronic, but it's very bird-like. Like it feels alive. It feels like it's kind of calling out to you, which is exactly the purpose of this thing. So that's good. But for the sake of argument, let's try a lower frequency as well, just to see if this same little pattern works better at a lower frequency. So we'll go down, let's go to 2500 to 2000, 2500. Oh, no, this is the higher one, so this will be 3500 to 3000. Now 25 to 2000 and 35 to 3. Okay, so we'll see how this one sounds. See, this to me sounds a little bit more metallic, a little bit more like an alarm. Like if I heard this, I would think something's wrong, something's been stolen. And we can go even farther down. We'll go 2000. No, I'm going to go 1500 and 2000. And then we'll do like 1000 and 500. And then 1000, or no, 1500, 2000, and then 500 and 1000 again. Cool. So we'll save that again. I like this better than the last one. But honestly, I think I still prefer the bird noise. Okay, so now I just got to remember the frequency that was at. So I think it was 4,500. Yes, this is the low one. So this I think was 3,500 and 3,000, maybe. And then this one was 4,500 and 4,000. Correct me if I'm wrong, but I think that's the thing that we're talking about the bird with. 40,000, or yeah, 4,000 rather. 35, 30, 45, 40. Cool. So hopefully okay, so this is where we are now. I'm going to bring it up by 250. 750. And at this point, we're really tuning. 75, 25, 25, 75, 25, 75. That's it. Cool. I think I like this one. I think this is going to be it. I'm going to try one more thing, which is to speed it up. I'm probably going to come back to this though. So I'm going to increase the fade decrement speed to 3 at a time instead of 2 at a time, because this is a bit of a longer one. 4. So here it is, decrementing by 4 at a time. I think the 2 is best. I'm going to try 5 just out of interest, but I think we're going to go back to 2 at a time. 5 sounds pretty much the same as 4. So I'm going to go back to 2. Then it is more bird-like. It's like distinct little tweets, as opposed to this, which is like, I don't know, it's a little bit more like one sound with just multiple notes. Almost, it's kind of getting close to a chord almost. 2. So here's and you know we're creating a first draft here, right? So it might be changed later, but I like this. There's our sound, wonderful. Now those are our 3 normal random event sounds. So let's go through them real quick, just to sort of refresh our memory of what we've done. So squeak 0 is this wonderful little tritone. Okay, there's squeak 0. Here's squeak 1. So we just created squeak 2. So after spending that time tuning squeak number 1, I think I'm going to go back and tune squeak number 2 a little bit. I'd like to try, a moment ago we mentioned inverting kind of the direction of the sound. So instead of decrementing, incrementing, I'm going to try that out. So we're going to go from 1250 up to 2000 as opposed to from 2000 down to 1250. This is on squeak number 2, which is like the boo boo. This is going to be 1250 up to 2000. Cool. We're going to go plus equals 1 as opposed to minus equals 1. Plus 250. And then it's going to be up to 1000. Problem on line 125. Let's see, something went wrong there. I'm not totally sure what it was. So 1250. Oh, well, it's less than 2000. Got to change those around. And well, this is less than 1000. Cool. So here's that sound. I kind of like this. I think I'm going to speed it up a little bit. So I'm going to go, we're going to now increment by 2 as opposed to just 1. Try 3. I'm going to do 3 for the first one, 2 for the second one. 3 for the first one, 1 for the second one. That's it. I like that a lot. I'll try it the other way around with 3, with the longer one first as opposed to second, but I think that first one's going to be it. So 3. Two. Okay, so here's what this, oh, sorry. Here's what the long then short sounds like. So I think I'm going to go with the short then long as opposed to the long then short. So we'll go 3 here, 1 there. I really like that effect. So short, long, really cool. Awesome. So here, those are our 3 existing behaviors. We just need 1 more for when he gets picked up or moved around, but it's most likely going to be when he gets picked up. What should he do? Um, let's see. So what do like animals do when they get picked up? So if it's like a wild animal, it's going to make like some sort of an alarm sound, right? It's going to scream. It's going to make an unhappy sound, right? And try and get away. If it's like a pet, it might still do the same thing. But if it's a friendly pet, it might purr, right? It might make some other sort of gentle sound. So all of these sound effects are very like kind of high, right? High and electronic and kind of buzzy. Maybe we could have him try and do like some sort of a purr effect, like a low frequency purr sort of thing. And we'll just have to see like whether or not that's possible with the piezo element. I'm thinking maybe. I guess that's what most of engineering is, right? Just thinking maybe. And then hopefully it works out if you've prepared enough and planned enough. So, just checking on our stream. We've been going for about an hour and 40 minutes now. Awesome. So next, what we're going to do is, create this little, create the purring sound for when he gets vibrated or touched. And if this doesn't work out, if we can't get sort of more of a friendly sound, then we'll go with something a little bit more alarm. But I want him to be happy. I want him to be friendly. Kind of like our own little Tuco the cat, if you watch any of Micah Scott's stuff. So I'm not elite enough to make a Tuco flyer kind of thing, but we can make a little friendly robot that can purr and hang out with us just like that, which is kind of fun. So my thought is we'll do another one of those fade tones. Nico, thank you so much for suggesting that. It's fantastic, but we'll stay in like a real low frequency range for the whole thing. So I'll just get rid of this. Fade frequency equals, let's try like real low. Let's start it out at like 100. Hopefully this won't sound too gross. If you remember from the first stream, I talked a little bit about I considered just using like an amplifier board and a real speaker, which would have been better for something like this, but it consumes a ton more power. Would have taken up a lot more space. Whereas a piezo is just sort of meant for this sort of thing. So now we're sort of starting to come to the trade-offs, like real low frequency stuff or sounds with a little bit more like character, if you will, that's not just kind of digital sounding. We sort of give that up with this lower power, lower complexity piezo. So while fade frequency is less than, let's say, 150, this could be like a real slow fade too. So piezo dot frequency equals fade frequency. Piezo dot duty cycle equals 65536. Divided by 2. Time dot sleep not 1. Fade frequency plus equals 1. And we actually want this to be significantly slower, so I'll make it an order of magnitude slower first, and then we can play around with it a little bit. So piezo.duty cycle will bring this down. Copy, paste. Okay, so we'll try number 3 now and just see how that sounds. Nope. Oh. It's the typos. You know what I mean? It's the same things that dog you in Microsoft Word. Same problems you have with this. Okay, so that's, I'm not even going to bring that up to the camera. That's just bad. So I'll make that not 0.1. Okay, I kind of like this, and I'm interested to see what you think. So if you are watching, please let me know what you think. It's just kind of like a little low buzz, and it does communicate emotion. Like it's very, I don't know. It's like if you had a little robot, right, and it were to purr, a purr is just like kind of almost just like a sigh, but with feeling. And so this is kind of like that, right? I think we're closer than I expected to be with this. I'm going to try bringing it down in frequency a little bit, and we might, this might become just garbage, or there might be no difference. We'll change this to 25. Okay, so here's my thought. So we right now have this going from 75 up to 125, and it sounds like this. Okay? It's just like an increase. So what I think I'm going to try is having it go from 75 up to maybe like 115. Okay, so it's not quite reaching, not getting quite as high. I'm then going to speed that up a little bit, 0.75, okay? And then I'm going to also have it go back down again right away with no delay. So that's sort of a, which I think is going to add a little more character, a little bit more interest to this. And we want, we want this vibration, this motion event to be kind of special. So it's okay if it's a little bit longer than the other ones, as I think it already is, really. So we'll copy this, paste it there. We already have our fade frequency. It's going to already be at 115. So while it's now greater than 75, cool. Now we're going to decrement. So we'll save that. I'm going to have this go. I'm going to go back to 125 because you can't really hear the difference. Okay, so here's what it sounds like now. So it's not super expressive. No, it's expressive, a little bit long, and you can't hear the variation as much as I had hoped. So I'm going to decrease this to 50. I'm going to decrease this to 50. And then we are going to increase this to 2. So now we're going to be ranging over that frequency range a little bit quicker. Um, that's it. That's it. Actually, I think I'm going to decrease this back down to 115 as opposed to 125. And I'm going to decrease this to 0.65. And remember, because this is looping so many times, the minute changes in this time.sleep thing are actually going to have fairly significant effects on the overall time that this takes. And we can hear Rigatoni over here. Almost forgot his name. That is horrible. I'm a bad parent. Kind of beeping in approval. So I like it. That's our little purr sound. Very cute. Perfect. With that said, we now can move on to our well, I guess it's just like our event code. So what we have done so far is we have this random number thing that basically makes it so that about 2.5% of the time, normally when the robot's just sitting there, it's just going to have both eyes on, not making a sound. 2.5% of the time that it loops through this, however, because this is a pseudo-random number generator, it will be weighted somehow, it will do an event. 1/5 of that time, it will make a sound, and it will blink or do something with its eyes, and then the other 4/5 of the time, it will just blink or do something with its eyes. And we have that set up here. That's not really affecting anything right now because it's unlikely enough that this will happen that we're not seeing it occur over the time scale that I'm showing on camera, especially because we are delaying every time 1 second. So it's not just free running here. I know that's not the right term, but whatever. I am real quickly going to post again on my Twitter about the stream, just kind of as we move into this next section. I always forget where on the little YouTube stream page the link is, like the public link. Thank you for your patience if you're watching right now. CircuitPython. DIY noodle feet. Awesome. Okay. There goes the tweet. Prepare for millions of screaming fans to join you in the chat. Fantastic. Or perhaps, yeah, 1 or 2 screaming fans, but all the same. You're all fantastic. We are now going to move on to that randomness. Pseudo-randomness, I apologize. So I'm now just going to comment this out. And since we now have, the other thing that we have right now is we can generate any number between 0 and 3. For the sound, we only want to be able to generate a number between 0 and 2 inclusive, because the number 3 is for the vibration event. But eye behavior, we can do any one of them. So I'm going to save this real quick, and we'll see if we can actually observe a behavior at all. Okay, we have a problem. So 134. Uh-oh. Rand is not defined. Do I need to include that? I might. Yeah. So include I think that did it. Okay, so we still have a delay down here. I forgot about that. So basically what we want to be doing right now is just running this loop as quickly as possible. And eventually one of these random events is going to happen, right? Or pseudo-random events. And then we can see how quickly it's actually going because it'll print loop every time to the terminal down here. It's going crazy quick. And as you can see on the camera, there are a lot of events happening. But it is working. One sec, let me switch over to the desk. So there's the close-up on the actual board. I can rotate it a little bit so you can see the eyes a little bit better. And then hopefully you can hear. So you can see that the eyes are just going bonkers. So we have a lot of different events being triggered, but they're not being triggered constantly. Occasionally there is a break, which is a good thing. It means that we're not just constantly triggering events. The random thing is working, and then the sound is only happening occasionally. So I'm not sure whether you can hear it or hear it well. So whenever there's a sound, I'm just going to say sound for a few moments. So just listen so that you know kind of the frequency of when the sound is happening. Again, that should be happening 0.5% of the time. Sound, 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 sound. So it's way more frequent than we want, but it's not constant, which is great. So that means that this is working. We just need to mess around with the frequency a little bit, and not the frequency of the sound, the frequency of events being triggered, which is somewhat easy to do, which is nice. Let me switch back over to my computer scene. Sorry about the tunnel vision there, and here we are back in our Mu editor. Rad. Okay. So to change this, I'm going to see. If you recall from the beginning of the stream, we don't want to decrease the frequency with which we're with which we're testing a new random number, because we also need to be polling this sensor. Actually, no, we can decrease the frequency without decreasing the frequency of the overall loop. So we'll do that. So what I'm going to do here is I'm going to create a new variable counter up here in my non-loop code, loop count, and we're going to set that to 5,000, or 5,000. or no, we'll set that to 0. Then, hey, welcome to the stream. Just saw that someone joined. Oh, hey Sam, how's it going? So loop count is 0. So now every time that the loop runs, we're going to go loop count plus equals 1. So now down here, we can check if loop count is greater or equal than, or greater or equal to 5,000. Then, only then are we going to check this random stuff. So basically what this allows us to do is, without using larger numbers within this random generator and checker, we can just check it less frequently to have events trigger less frequently. So in theory, this should make events trigger about 1/5000th as often, while still maintaining and actually increasing, because we're not running this every time, increasing the frequency of our overall loop so that we can pull that motion sensor, vibration sensor, quickly, which is great. So I'm going to save this, and we can see how it plays out in hardware. Huh. Oh, okay. So what happened there was I just forgot to reset loop count. So loop count equals 0. Cool. So it took a while to do anything, and then once it did, it just went really, did a whole bunch of things really quick like it was doing before. So now it'll count to 5,000 and then check this. So something happened there. I think that we may have some code up here. And this, I think this loop thing is actually kind of slowing down my computer, having to display those so quickly. So I'm going to comment that out and resave, because we know the loop's working. It's not an issue at this point. Cool. Yeah, now we're back up to speed. So up here, I think in the eye behavior, we have something that's leaving one of the eyes on after it's finished. Oh yeah. Don't know what that's for. Great. So down here, the other thing we forgot to do is just every time that this loops, since none of the behaviors occur or carry on between loops, we're going to do is just, by default, turn both of the LED eyes on. So the names for those variables are right eye and left eye. Right eye dot value equals true, and left eye dot value equals true. Cool. So that way we make sure that when it's not in the middle of a behavior, those eyes are being kept on. And while I was working on those couple of things, there were actually a couple of behaviors that were triggered, but I don't think it's quite often enough. So I'm going to decrease this to 3,000. So now it's going to do this random generation and checking once every 3,000 loops, as opposed to once every 5,000 loops. So hopefully it'll make the events a little bit more common. Oh, issue on 138. All right. think we can just remove this at this point. 131. Loop count plus equals 1, that's good. Where is our issue? $133. Hmm. $131. $132. That is weird. Okay, so it's not stopping at the same place every time. Print loop. Line 51. Looks like there's some issue with this dot star thing. You can comment that out, but shouldn't be having issues. Did I mistype something here? Dot value should be both true. Left eye and right eye both set to true. Yep. All is as it should be in that regard. Let's see if our loop is running at all. Right eye. We'll turn the right eye off. Blink it. Dot value equals false. Time dot sleep 2. Okay, it's running. That's all right. Now when loop count is greater than or equal to 3,000, yes, I mean this should now be working. Change this down to 1,000 to increase the frequency of our loop, or of that test, I guess. Oh, okay, there's behavior. Just blinked the left eye. Just blinked both eyes. I'm going to switch back over to the desk view so you can see what's happening there. I'll try and bring this up a little bit so it comes back into focus. I'm really loving this new webcam. It makes it a lot easier to see what's going on. So let's just watch this for a moment. So this is now testing the random numbers once every 1,000 loops of the main program loop. Okay, got some directional blinks and winks. Is there sound? I think this is it. So I don't know if you've been watching. I guess he's kind of covered up by chat, but this is OG Serapetkus Canon Baby Noodle feet right here. And you can see how often he does stuff. This guy's a rigatoni. His friends call him Tony for short, though, and we're all friends here, so that works out. They just blinked at the same time. It's so cute. Ah! Blink. Okay. This guy just made a sound. Just made another sound. Rigatoni just made a sound. Yeah, I think this is just about perfect. We have very similar event frequencies on those on that pseudo-random loop. So that's fantastic. Because I think that's something that Serapetkus, well, she nailed the whole thing. But I really like the frequency of events. It feels organic. It feels like just kind of feels like having a little buddy around, and it doesn't get boring. It doesn't get annoying. It's something you can just sort of keep on your desk, as I've done for this whole stream. He's been on and going, and it just sort of feels like an atmospheric, just like a living thing hanging out with you. And so I think if we can replicate that part as closely as possible, we're making a few changes here and there, but that part I think I really want to stick with, and I think we've done it pretty well. That's awesome. So I'm going to switch back over to the computer view, and we can work on our next little part of this, which I guess is going to be the motion sensor. One sec, let me switch back to the computer view. Sorry about the tunnel vision. And there is our gorgeous mood text editor. So just sort of a recap. We have created light eye effects, which we did in the last stream. We have created our sounds. Thank you to Nico for the fading frequency idea. It's fantastic. I love how they sound. We have created our random event loop, which makes it so that most of the time our little baby noodle feet brain is just hanging out, sitting around, but every once in a while he'll say something or blink his eyes or wink or whatever to let us know that he's very much alive, very much present, and wants some interaction, wants some friendship. We have our, the one thing that we have left to do, the one sort of central thing, is the sensor, the motion sensor, which is also our biggest addition to this project beyond the Marshmallow brainboard. So the idea behind this is when we interact with Noodle, when we flick him a little bit, whatever, he'll be able to respond and have like a special sound that he makes, and he'll do an eye action and stuff like that. So it's going to be really neat. So to do that, we're going to uncomment this code. So sensor is the input pin with a pull-up enabled that is attached to that vibration sensor. So when it's vibrated, it will call this moved. When it's vibrated, that pin will be pulled to ground. It will call this moved function, which is up here. So right now we have that printing out movement detected. It'll change the color of the dot star on board, and it will then sleep for 2 seconds, which is cool. So real quick, I'm gonna re-enable the dot star, the normal dot star. So when nothing's happening, the dot star is just straight blue. And then when the movement's detected, it turns red. So that's kind of a visual cue, and we can also watch the monitor down here to let us know when that changes. So I'm going to save this code real quick. Again, that goes straight to the board. Now, remember, our concern here is that we don't have interrupts. So hopefully our loop, our program loop, will be moving quick enough to pull the sensor quick enough that it can catch it for the very quick momentary closed circuit that will happen when it's vibrated. So let's try it out. I think I'm actually going to switch over to the desktop view for this. So again, this should turn the LED on board, which is blue right now, should turn red when it's vibrated. Not a good sign that nothing happened there. Oh, it went red. Okay, so it can catch it. It can catch it. Look, so when I flick this little vibration sensor, that's what's triggering it. And the dot star LED on there goes from blue to red, which means that it is being caught. However, as you can see, it has to be a pretty big vibration, and it's not being caught every time, which is just a result of our polling. Oh, hey, DR. Welcome back. DR was in the stream last weekend, so I'm really glad you can see where we are with this. We've been working on the code. We got the sounds working. We got our randomized event loop working. And right now, you may remember last week I talked about the vibration sensor. We're working to get that up and running. So it looks like our polling approach is working intermittently, but it is working. And because we don't have interrupts, I think we're going to have to kind of make peace with a less than perfect solution. But let's see just how good we can get it. The best thing we can do right now is to speed up this loop so that it's checking that pin more often. So loop count we need. That's affecting the timing for our events. We need that. Right eye dot value equals true, and left eye dot value equals true, which are turning our right and left eye lights on when no event is happening. We actually don't need those here, at least, because up top, all of our eye events leave the lights on, leave both eyes on at the end. So if we just at the very beginning of the program, outside of the loop, turn both of those on just to start, that's all we really need. So we can just put that up here, and we're good to go. So this is going to make it so that the program doesn't have to set those pins every time. Perfect. So loop count, again, we need the dot star. Do we need the dot star? Okay, well, I guess this is another case where we need it once at the beginning, right? But we also need it because remember the way that we're testing, at least right now, for how for whether or not the sensor has been triggered is that the dot star goes from blue to red. And I actually want to keep that behavior to sort of show that, you know, Noodle's brain is glowing like a different color when he's sensed some movement. I think that sort of adds to the sound behavior that we have for that and those sort of things. So I'm actually going to, first of all, we need to make sure that after it's moved, it goes back to blue, right? So that's good. And then we can also just move this up to the top. So when the program starts, the dot star will be set to blue, and then whenever that movement sensor is triggered, it will be set to red, and then right after that, right back to blue. But then when it's just looping and nothing's happening, it can just stay blue, right? We don't need to be constantly telling it that. And I'm not sure. I'm not totally sure what's happening under the hood with these dot star commands, but I would imagine this is probably a pretty intensive command. It's probably not very quick. So hopefully we'll have just shaved a pretty significant amount of time off of this loop so that this sensor.value can be pulled much more frequently than it was before. So let's save. Oh dear, okay, I forgot. Okay, I feel kind of dumb about this. I forgot to switch back over to my computer view. Sorry, my bad. There we go. Okay, so we're back on the computer view. Sorry about that. I was just talking about code that you could not see. But what we just did was we Before we had been turning the eye lights on here and setting the dot star to blue every time, but now we're just doing those things when they need to be done. So saving some overhead, saving some cycles so that, thank you, DR, I appreciate your forgiveness. So that every time it loops, it can be pulling this sensor a little bit more quickly. So we'll save this. I seem to have an issue, perhaps, on line 149. I think we're actually okay. It seems to be running. So now I'm going to switch back over. This time we'll remember to go back. So keep an eye on that blue glow. So when we flick this, okay, this time it worked right away. So I need to make sure I hit it hard enough. Okay, I think it was that dot star command that must have been eating up a lot of time on every loop. But now, let's see. So I'm going to flick it pretty hard. So every time that I flick this, it should go off. And we'll try this 10 times and see what percentage of the time it actually triggers. So there's 1. Cool. 2. Okay, that was not a very hard hit. I'm not going to count that one. So that's 2 for 2, 3 for 3, 4 for 4, 5 for 5, 6 for 6, 7 for 7, 8 for 8, 9 for 9. Woo! 10 for 10. Okay, so we're now definitely pulling that vibration sensor quickly enough that it can detect when we get that. Yes, if we made it faster, it would look almost like a police light. Yes, so, the idea here is that hopefully this won't be going super frequently. It just, when you're picking up baby Noodle feed or moving them around or something like that. But you're right, it is a little bit police-like. Thinking of that, I think what I might do is actually change it so that it's green and red, maybe. Huh. I'm not sure. We can try that out pretty simply here. We can just see how that green looks. I might also turn up the brightness a little bit, because when you're looking at this directly, I like this brightness, but if we're using this dot star sort of more as like atmospheric to light up the skull, it might not be quite so good. So 3, we'll go up to 0.5%, or 0.5 out of 1 brightness. And then we can also change our normal, not being flicked color to green. 0. 255. We'll save. Beautiful. Okay, so now it's a little bit brighter. Okay, again, I forgot to switch back, but all I did was just change that color and made it a little bit brighter. So here's our desk. So we just made that green. It doesn't show up quite as well on camera as the blue does. So there's the green, and then we flick it, it goes red. Works the same way. I prefer the blue. I'm gonna go back to the blue. It looks kind of like a police light, but I'm cool with that. 255, and one second, let me just switch back to the computer real quick. Not this again. There we go. Okay, so it does seem to kind of take the computer a moment to load. It's probably my graphics card. So we've switched over to, we switched back to blue in both places here. 0, 255. And then I'm also going to first test it out with this higher brightness. So I might end up going back to that 0.3 brightness as opposed to the 0.5 I just bumped it up to. it does seem to kind of blow out the color when you're at higher brightness. So there we are, saved. And as you can see, I'm not going to go back to the full, I guess I will go back to the full desk view. I prefer the blue. And honestly, I think I prefer it at the lower brightness too. So I'm going to go back to computer. There we go, okay. So I'm going to go back to 0.3. It just seems a lot more saturated at lower brightness. So I'm going to stick with that. So let's see, is this kind of it? Oh, no, okay, not quite. So we need to actually write this moved function. Okay, so we don't need to print that because most of the time it's not going to be connected to a serial monitor. We do want to be setting the dot star to red. That's still good. We do want to run, we want to run our special sound, right? So that's going to be squeak number 3. I'm really glad I named this function squeak. I think that's very cute. Very noodleicious. Squeak 3. And I'll play that for you in just a moment. So that's cool. And then we also want an eye movement. I'm comfortable with this just being like the same eye movement every time. I'm going to have this be eye behavior 1. Or no, 0. So that's just the blink. So whenever it's moved, I'm actually going to have it do the eye behavior right before and right after 0. So it's going to blink real quick, do the movement squeak, and then blink again. And then wait 2 seconds. So we'll save it. Cool. Flick it. I almost like the idea of his eyes going off during that action, because we talked a little while ago about that sort of being like a happy thing, like a purr. I think I'm going to have his eyes go, or at least we can try. We can try this out. Again, we're prototyping more or less, so not going to have it do an eye behavior. I'm going to have it red eye dot value equals 0 or equals false. I'm going to have it sort of blink, or I'm going to have it wink off, and then left eye dot value equals false with a delay of 0.5 in between. Cool. Then we're going to have, then it squeaks, right? And then it's going to do red eye dot value equals true. Left, or now we're going to time dot sleep, not 0.5. Awesome. Okay, so we now have right eye, left eye. So let's try this behavior out once. That is now saved. We can switch over to our desk scene. And I will So this is really annoying that like it takes OBS a few seconds to sort of pick up the display. I'll just kind of wait for this to come back so we're not rushing ahead. Come on, you can do it. If it gets stuck, that'd be a real shame. Because we're very close here. Okay, well, I tell you what, I'm gonna, let's see, if we hide computer monitor, bring it back. Yeah. The computer monitor is not happy. Oh, there we go. Okay, got it. Awesome. It's just weird, man. Okay, we are back in action. The computer monitor is working. You can hopefully see it. Awesome. Here we are, back in Mu, whatever. So I like that behavior. I do want to speed up the eyes going on and off a little bit. So we'll go to 0.2. Let's go to 0.1 on that. 2. Change my mind. 2. I wish that the piezo is a little bit louder, but that's what it's going to be because it's 3 volts as opposed to 5. It would be neat if the eyes sort of dimmed instead of went off. So instead of doing something fancy with PWM, I am going to just do a little loop. So for left eye, well, no, okay, so dim count, I'm just going to create another variable. Dim count equals 1000 while dim count is greater than 0. Left eye dot value equals not left eye dot value. Okay, hopefully that works. And then right eye dot value equals not right eye dot value. Okay, cool. So I'll do that 1,000 times. And then we want this to be a little bit staggered, so I'm going to delay time.sleep. Actually, this should be happening while the sound is happening. So my idea here is we're going to have like the eyes kind of dim just by blinking on and off really quickly. However, if we do it here, outside of the squeak function, what's going to happen is that they're going to dim, then they'll be on or off totally while the sound is playing, and then they'll maybe dim again, depending on what we do afterwards. Whereas if we totally take this out of the moved function entirely and put it inside the squeak function, which in terms of structure is not very neat just because of what our functions do right now. It really expands the role of squeak. But I'm okay with that. Let's do that. So, and remember, this squeak number 3 is only being done during the moved event, during the moved function. So that's okay. It won't be just like randomly dimming during the randomly triggered events. So here, yeah, so every time that this runs, we will just do left eye dot value equals left eye dot. Oh, actually, we want these to be like staggered again, as I said before. So these should be on opposite sides of time.sleep. The right before time.sleep and the left after time.sleep. So right eye dot value equals not right eye dot value. Cool. And then on the other side of this, left eye dot value equals not left eye dot value. Beautiful. Now we can bring this exact same thing down into here. Delete that. Just paste these guys in. So now we're gonna have the eyes sort of dimming and flickering, probably dimming because this is a very quick action. So we probably will not be able to actually see them flickering. It'll probably be more apparent as a dimming effect, but we'll see how it goes. So I think this is now good. I'm going to save it. Oh, issue on line 125. So it's not liking this. I think maybe we need one of these guys. That appears to have worked. So let's see. I am very reticent to leave our desktop, like our computer view right now. So what I'm going to do is just tilt up the brainboard a little bit so you can see the eyes better. And that is having essentially no effect on the eye brightness, doesn't seem. So so the idea here again is that it's switching them on and off. I forget this. I'm looking up the Python symbol for exclusive OR. Okay, I guess we can just do the not. Okay, so it looks like the way to do this, the Pythonic way to do this, is just to do not equals. Maybe. This seems really sketchy to me, but let's see if it works. Is it running? It is running. Um, yeah, there's no, if you can see in the bottom right corner of your screen, there's no visual change to those LEDs. So let's see if we need to change something else here. Um, hmm. um, I may just let this go. Can, however, try if write I dot value just to see if this is just me or it's just not, it's not a visible effect, period, even if it is happening correctly. Equals false, else write I dot value equals true. Cool. So we can save that. Now when we flick it, yeah, it works. Kind of. It looks really dumb, but it works. I guess we can just copy and paste this around. So I'll try it on both sides. We may just end up deleting this because it, from what I just saw, it does not look very good. But when it's both eyes and it's happening for the whole duration of that tone, perhaps it will sound better. So I'll paste this down here as well. Left. So now it's going to be happening on both eyes, not just the right eye. Awesome. We're going to save that. Okay, that's fun. You got to admit that's fun. So normally they're just both on unless there's an event going on, but then when we flick this, they flash on and off real quick. I'm confused by why they're flashing on and off so slowly, but that is what it is. There might be some capacitance, maybe? That doesn't make a lot of sense. No, that wouldn't be capacitance. But when we hit it, he does that. So he does the little blinky thing. That's cool. I'm not entirely confident or, happy with the fact that it's all red at that point, the eyes and the dot star. But I mean, it is, I think within the limited scope of this project, it works well. What I might try doing here is increasing the brightness of the dot star. So dot star 0 dot star dot brightness. Is that a thing? We can see. Okay, now if we comment, so I don't know if you saw that. Here's what it looks like now with that brightness turned all the way up when this is triggered. Well, if we remove that line, so it's just going to stay at brightness 0.3 the entire time, can save it. There is no appreciable difference. I'm going to change this to .*0.brightness. Save it. That doesn't run. Doesn't have an attribute called brightness. What happens if we turn this up? Like, I'm just playing around with colors at this point. Goes to kind of an amber. I like that. Also kind of an amber yellow. So just to kind of bring it back, what I'm trying to do here is communicate a sense of like a happy interaction with this robot. And so I want it to be able to respond in some way. What we've done is we've created sort of a low purr. And I feel like almost what we have right now is, you know, like in Charlie Brown, where their mouths just like become scribbles when they're almost like kind of like overwhelmed or like confused or I don't know. I'm not totally sure what the word is, but just like I guess just really like overwhelmed. Then that's sort of what we're going for here. Is just this feeling that Noodle is being like impressed or overwhelmed with happiness and just with interest in being interacted with and touched. And so almost just kind of like blissed out. So like his eyes are blinking. I think I don't want him to just go red because is that okay, so DR is saying in Turkish it's called Dershan or Dershane. Is that how it's pronounced? I'm not totally sure, but yeah, I mean, we don't really have totally a word for that. But if that's what it is, Dershane or Dershane. But yeah, I mean, that's what it is. So I kind of like the yellow. I like the blinking. I like the sound. And I mean, the other cool thing about this is, you know, you do sort of have to flick it, or, you know, if it's dropped, God forbid, this will be triggered. But it's sort of like an Easter egg because, you know, in just sort of picking it up and moving around, maybe when you set it down on a table, but you're not just going to instantly be able to get this response just by, you know, touching Noodle. So that's kind of neat. So I think we're kind of done with the code, right? I can't think of anything else to add here. I'm going to get rid of this test code that we had for the eye behaviors earlier. I'm going to call this good. I like this. I like this yellow. It's not perfect, but it's good. DR says it is very early. Then DR, we changed accounts, and Aaron, will look the video. Okay. Bye. Thank you so much for watching, and I hope that you have a good sleep. I know last time you were watching the stream, you were saying it's like super early in the morning. So thank you for watching, and I hope you enjoyed. I'm glad you got to see like the last bits of the code here. That's fantastic. Liking the yellow. Wish we could make it brighter. We don't seem to be able to make it brighter, or at least not in any noticeable way. And I'm liking the rest of this code. I like the sounds. I like the eye movements. I think that's pretty cool. So I'm going to call this good on a software standpoint. Woohoo! Did it. So real quick, I'm just going to add a description. Wrong comment. DIY. Oh, I also came up with a name for this guy. I'm going to call him Soba. Again, keeping with the Noodle theme. So this is going to be the brain for little baby Soba, Noodle feet. DIY Soba. Brain code Soba, baby Noodle. Code. Again, title. Designed. Designed for use on the Adafruit Trinket M0. Board. With in a Noodle spawning robot designed by Sarah Peckus. Forget her GitHub. I'm just going to look that up real quick because I want to be able to give proper attribution in this. That's important to me, very important to me. I guess I can just give her website. That might actually be better. So Sarah Peckus, who created this, is an awesome artist. Does sculpture, a lot of like comics and drawings. She's super cool. And she, and as well as Micah Scott, are the people who really sort of inspired me to create this, to start live streaming. So Sarah's website is Zones. So I guess I'll give that. Zones.com. There's my website. Trinket M0 board and a noodle spawning robot designed by Sarah Peckus. And I know this doesn't actually serve as a license just to write MIT license in here, but we'll put the license in the GitHub, and it's just good to be clear with that. So about baby noodle feet code. Okay, so I think that's properly attributed, at least for now. You know, obviously there'll be a lot more details in the GitHub, but that's the code. I'm going to call that good. And now, before we install Soba's brain into his body, which is going to be a very dramatic and very emotional and beautiful moment, I'm going to first try out I don't know if you remember from the very beginning of the stream, I mentioned that the 12mm battery pack that we have on this guy right now just was not cutting it. So I picked up this, which is a 20mm CR2032 battery, which I believe can provide more current. I'm not 100% sure, but I believe it can, and hopefully it'll be able to power this. So first of all, I'm going to test out this thing just under battery power with the existing battery to see if maybe the current consumption has changed with our new code. So we can test that out. I can't believe we finished the code for this. Thank you all so much for watching along with me and for participating. Got some really good tips on what to do with this. Okay, so it is on, but the LED, maybe that's the bootloader LED that's blinking on the dot star. It may just be kind of browning out. I'm going to reset it. Wait. No, dude, it totally works. Ah! Okay, so the issue we may be having, I don't know if you noticed, but the dot star is not on when we're not in this like tapped mode. Which may be because the blue LEDs draw more current, significantly more current, than red or green LEDs. So that could be the issue. However, I'm just going to check real quick to see if maybe we made a mistake in the code. I'm just going to plug this back into USB real quick. First, I'm going to remove the battery to make sure that's not what it's supposed to be doing, because I may have just made a mistake. I apologize for consistently using the wrong tools, but whatever. Okay, so there it is. Flick it, makes the sound. The sound is significantly louder on USB power, which is telling, and the blue LED is on in USB power. Okay, so that means it's almost certainly a current issue with the battery, which is solvable, right? I mean, we were planning to make this change right now anyway, so that's cool. So I'm gonna actually have my soldering iron right here. I'm just going to plug this in. One moment, be right back. And I'm back. Turn our temperature up a little bit here. So I'm just going to desolder the 12mm battery pack and solder in the 20mm battery pack for the 2032 batteries. Very unsure whether this will work. Frankly, if it doesn't work, I'm totally okay with not having that blue LED and just having the yellow LED that comes on when, and only having the yellow LED that comes on when it's flicked, when the robot is flicked. Real quickly, this focus is, honestly, it's okay at this point. That's pretty good. And we'll try and avoid getting a whole bunch of smoke and other stuff on the lens from soldering here. This will be a pretty quick little job here. Luckily, I used these stranded silicone wires, which stand up much better to the heat of desoldering than the normal kind of PVC coated wires that I normally use would. I also, in the last stream, I'd forgotten my tweezers at work, but I have them. I brought them back in my backpack. They are right next to me here. This is fantastic. It's always a good day when you don't have to burn the crap out of your fingers. So we can just get in there, hopefully. There we go, there's one. And the other, perfect, we're desoldered. Easy. And I'll actually probably use this pretty soon because I still have the battery. I haven't really used this like at all. And I actually have like a Gemma, Adafruit Gemma sitting around. I might try out like a few other little microcontroller projects that this would be perfect for as a little 3-volt supply. Awesome. So now we have this, which is really not meant for this sort of point-to-point soldering, but I think it should be fine. I'm going to pull the battery real quick out of it. I love this new camera because it means that things are in focus. Not right now, but what I actually want to focus on is in focus. Everything but me is focused. So this is, yeah, this one is power, or this one's 3 volts, the other one's ground. And this contact is power, so we're good, we're in the right spots there. Since these wires are already tinned, we should just be able to kind of tack them on here. And these are very low current connections, relatively speaking, so don't need to worry too much about getting this totally perfect. Although I will do my best. Whew. Not quite enough solder there. There we go. Okay. Does it look good? Hell no. Will it work? Hell yes. Now again, we would have utterly destroyed any PVC coated wire by now, just even within these few seconds of heat. Nice to have a lot more working time with this silicone wire. That one's not happening there. Not working out very well for us, so I'm going to add a little more fresh solder. There we go. And those are two exceptionally ugly, but undeniably complete solder joints. Perfect. We can now experience the moment of truth. We'll plug the battery in to our little battery holder here. And it appears to be, yeah, so I think when you just plug this, when you just put a battery in there, not connected to USB, it goes into like a bootloader mode where this little yellow dot star flashes. And then in a minute it'll change to actually running our programs. Let me sort of get this up and into a view where you can actually kind of see what's going on the board. Okay. Just flashing, doing its thing. I don't know about this little bootloader thing. I'm going to hit reset. There we go. Okay. Now we're in business. Perfect. The battery worked. So this 2032 battery is evidently providing significantly more current, enough to light up this LED as it needs to be lit. When we flick this, it goes into our little action mode. Awesome! Awesome! Oh my god, we did it! Fantastic. So here's our little brain board with power provided by the little battery on here. We've got our little vibration sensor, piezo element, our left and right eyes independently controllable. It's really a thing of beauty, folks. Now, real quick, we could install this, but the issue is we now have these two exposed and very ugly, let's be honest, solder joints. Only a mother could love those solder joints. Which I guess is what I kind of am to this guy, but regardless, for your benefit, I'm just going to cover those up in a little bit of hot glue, just to protect them, and so that if there is a little bit of a tug on those wires, the force is going more into the hot glue than into the solder joint itself. One sec, I'm going to get down below the desk for another moment just to unplug the soldering iron and plug in this hot glue gun. There's the soldering iron. And hot glue gun. Need to get a better one of these. I just picked this up at like a CVS, but it takes so long to heat up. It's absurd. So I'm just going to fixture this a little bit better with my third hand tool here so that you can actually see what I'm working on a little better, hopefully. There we go. Oh, perfect. That's beautiful. And again, as I said earlier, I'm going to be open sourcing all of the code, and at least like the bill of materials. I think that maybe I actually haven't used anything like Fritzing before that would allow me to lay out this circuit in sort of a very easy graphical way, but maybe I could just like sketch that out as a way of open sourcing the circuit. But I think this is simple enough, like this video is kind of open sourcing the circuit in a sense. And you know, the trinket itself from Adafruit is obviously open source because they do that for all their products, which is super awesome. As well as, you know, CircuitPython, that's publicly available, and they're making their development process for that pretty open as well, which is pretty cool. Glue gun is still heating up. This is so exciting. I'm just going to drop in Twitter real quick that we're like done, and hopefully by the time I'm done with tweeting, we will have our hot glue gun all warmed up and ready to go. right, so we have our tweet. It's been composed. It is going out. Hopefully. Reload. Now our hot glue gun is almost up to temperature. I want to make sure that we're doing this right. May have just lost internet on my other computer, so that could be problematic. We'll have to see. Oh, no, we're good. Hopefully my streaming computer is on Ethernet, so hopefully y'all are still with us here. Okay, already sent the tweet. Nice. Ah, rad. So Soba is alive and killing it. Here we are. So with the hot glue gun now all heated up, I'm just going to hot snot these two solder connections. Make sure that they stay at least semi-intact. Try and get a good sort of seal over those. You know, this, I expect this battery to last for quite some time. They last quite a while in Sarah's marshmallow board. This is definitely a lot more power hungry than that is, but at the same time, I still expect it to last for several hours at least. And the great thing is this battery holder makes it super easy to replace the battery. So, kind of a big moment as we wait for that to cool. I'll just take this out of its little fixture. Awesome. This is so exciting. So here we have our little Soba skeleton. One sec, let me refocus the camera. Here in OBS, I can just do some little autofocus stuff here. Cool. So here is Soba, and here is his brain. That vibration sensor is getting triggered a lot more than I expected, just sort of getting picked up and stuff, so that's kind of cute. So we can just throw it, we can put the battery in there, his little battery stomach. Try and hold this so you can see it easily. Okay, the battery holder doesn't fit super well. So I'm going to have there's this little kind of protrusion on the front of it. That's going to stick out toward the front. Make sure the piezo is oriented up. Oh, and we also need to make sure that this, it's a bit of origami kind of getting it in here, because we have the little vibration sensor that's pointed up, intended to look kind of like BB-8. Come on. There we go. Brain surgery is hard. There we go. Got it. Got it, got it, got it. Maybe got it. Okay, that's pretty horrible. Let's be honest. Okay. We're very close. But as you can see, no cigar. what I may end up doing is attaching the battery outside of the skull itself. So first I'm just going to get this out of there. Need to be a little bit gentle because, I mean, these solder joints are not aerospace grade. There we go. Okay, so it's out. The brain board itself fits in there beautifully. As you can see. Again, the vibration sensor is a little bit of a hassle, but it works. Can we just push the battery through this? Maybe, please? Come on. Huh. So the issue I'm running into here is that the battery holder is big enough that it cannot quite stack in there with the brain board in a at all attractive way. So I'm trying to figure out a way to orient the two, even if I have to have the battery sort of hanging out the side a little bit to get those to work. I think what I'm going to do is I'm going to take my focus. Come on. Come on. There we go. Okay. I think I'm going to take my flush cutters and cut a little piece out of the side right there so that this little protrusion off of the battery holder can stick out the side, and then the brain board can be oriented forward as it needs to be, obviously. This is going to work. It's just going to take a little bit of modification where I was hoping to just sort of drop it in and be done. So I'm just going to clip a little bit there. Okay, there we go. So now we have this little focus. If I put my hand behind it, there we go. Okay, beautiful. So now we have that little chip there where we can put the side, this kind of protruding side of the battery holder. You can have it just stick out there. Cool. I'm also going to take some better pictures of this later today and post them to Twitter, so if you're curious as to what exactly is happening here, you might keep an eye out for those. Almost. Oh. So there are a couple of little standoff pegs inside of this that are sort of, we're kind of getting caught on a little bit. There we go. Just cutting those off. There we go. Almost in. Now we can use the piezo to kind of hold everything in place almost because it has that plastic enclosure on it. Okay. Getting there. So here's where we are now. Very derpy. Also pretty cute. Luckily, we haven't broken any of the solder joints or anything in this process, which is kind of the big danger.
Oh, is he online too? Alright. Is he the host of his party? So we're doing a squad. We're doing a squad. Are we doing a squad?
So I think the question at this point is, do I just kind of get this into the best position I can and then tack it down? I'm also just going to kind of trim these hot glue things a little bit because it's bigger than it needs to be.
Can you hear me? Oh, sorry. The service in my room is awful.
And we just killed our solder joint. Need to go back in on that. Damn. That's discouraging. So I think, at least on one of these, we don't want hot glue because that's really getting in the way in there and taking up a lot more space than we strictly need to. I think this one is okay over on this side. That's okay. But over here, I'm not going to use the hot glue. I'm just going to try and get a clean solder joint. Just going to pull the battery while I'm resoldering this, but that's frustrating. I thought we were pretty much there, but that's how these projects tend to go. Like the last 2% tends to take a fair amount of time. Here we go. Bring our helping hands tool over. One sec, I'll move this into view for just a moment for you. The only real design loss that we've suffered here is the fact that the vibration sensor is going to have to be kind of tilted off to the side. We may be able to mitigate that a little bit once we've made this adjustment, but it's not going to be quite as good, quite as BB-8-like, if you will, as I had originally hoped. Okay. Trying to get this into a position. Okay, there. Focus for a second. There you go, bud. Come on, focus. I'll manual focus it.
Wait, okay. He has to send me a friend request.
There it is. Okay. Solder this back into place. Tin the wire first. my tweezers so I'm not burning my hands. There we go.
There it is. Alright.
Much cleaner than before. And hopefully won't short out on anything as we're trying to install it, but we'll see how it goes. This is the sort of situation where it'd be nice to have just like a little bit of Kapton or something like that. I just don't have that on hand here. Trim off the excess of that joint. Cool. It's tough when, you know, size considerations become a big part of your, like, you know, the soldering joint itself. You know, not even the size of the components, the size of the soldered joint. Okay, so that's a lot more low profile than it was before. That's pretty good. No promises that it will stay like that as it goes in, but that's the idea. And we're still working, so cool. Bring our little soba shell over here.
The only ones that I have don't plug into for the iPhone. No, they don't. It's the Lightning connector. No, the ones for the new iPhone.
Wait, is this it? Does it work?
Wait, can you hear me?
Nice. Okay, so it's not perfect, but that's way, way, way better than it was before. I tell you what, I'm actually going to grab the hot glue gun, plug that back in again. Unfortunately, I let it cool down, but I think it's going to be worth it to sort of keep the brain board and the battery together in there, so they're not just sort of flapping in the breeze. Awesome. Again, just waiting for this guy to heat up.
I hear you guys well. It's about whether or not you guys can hear me.
Awesome. So it's, you know, it's not low profile because it's not one board. It's not going to be super clean, but I think this is okay. And we can sort, you know, before I hot glue it, I'll sort of finagle it so it's in the best position it can be. And I'm not going to hot glue the whole thing to the skeleton so that we can adjust it, take it out, change the battery, whatever else in the future. Because that's one of the big drawbacks is the fact that when it's in there, when the battery's in there, it's on. We don't have a power switch.
I'm going right. Hold me.
Is this okay? We're very close to heated up, just not quite there yet.
I'm going to tomato town.
Maybe 30 more seconds. But I don't know. I'm pretty happy with how this has turned out. It would have been cleaner if we'd been able to use the 12mm battery, but I think that it's worth it to be able to you know, be sure that we're not browning out. I think that's pretty big. And the fact that you may say, okay, well, you could have just given up the blue LED on the board. I think that the fact that that was happening made it clear that we were very close to the current limit, even on a brand new battery. So, you know, the issue is that probably within, you know, maybe like half an hour of use, might not have been able to supply enough current even to you know, power the processor or those other two LEDs. Whereas this, we know that we're starting from a position where everything works. So as the battery, you know, dies over time, you know, maybe as it begins to die, we just won't have that blue LED as opposed to the whole thing not working. So I'm just going to shoot some hot glue into there. Okay. Before it sets, I'm just going to try and get that into the best spot I can.
Can you still hear me, guys? I know. We have a lot of time. We have only 2 minutes until it starts stream, and then we have time until it even gets to where the circle is. We have a lot of time to walk around.
Okay, so I think that glue is pretty much set at this point. This is a low temperature hot glue gun, so there we go. Our little soba is complete. Look at him just kind of hanging out, blinking. Just winked at you. What a player. Here we go. So now, so in the meantime, the battery on Rigatoni has died. So I'm going to refocus, change the battery on Rigatoni, and we can have sort of a little, like, you know, ending beauty shot here. It's going to be perfect. Look at him just kind of cheeping away there. I don't know if you can hear the sounds he's making, but he's chirping a little bit. So I have a whole pack of these batteries here. The nice thing is now they run on the same battery, so it's easy to keep them stocked. Awesome. Here we go. It's our fresh battery. And, you know, this Rigatoni's battery, okay, so he is not quite dead yet, but he is very close. So I'm gonna pull the brain board out of there. As you can see, Sarah really did a fantastic job on this board design. It's so tightly integrated. Uses a ATtiny processor with just enough memory. Which, if you followed my Pocket Automata project recently, you know I can respect, because that was a bit of a struggle for me to get, you know, just what I wanted into just the right ATtiny processor. So there's our old battery, and here's our new one. But it's just great. I mean, look at this thing. Okay, and there it is, shining all bright and nice and perfect. Rad. So now he's up and running again. Here is Rigatoni. Over here is Soba. And they, well, to quote Forrest Gump, they go together like peas and carrots. Let's see if I can get down into an angle that's going to be, oh no, I can't, I don't think. Maybe I can. One sec, bear with me. I know it's dark, I'm bringing you back, one sec. There we go. Look at him. Ah! This is legit the cutest thing. Okay, one sec, I'm gonna focus.
Oh shit. Yo, revive me, revive me. No, don't come out, don't come out. God.
Ah, they're so cute. Look at my babies. Over here we have little Rigatoni, and over here we have Soba. Get that little hot glue gun strand out of there. He's drilling a little bit. A little bit of that hot glue gun drool.
Yeah.
Tried to focus it there. Did not work at all. I'm doing my best. Hopefully that's a little better. Look at them. They're so cute. They're so cute. Ah. I'm going to bring them a little bit closer so that the camera really knows what it's supposed to be focused on here.
Not on the.
That is not happening. Aren't these guys just the cutest though?
On a computer.
Okay, there we go. Now we're in focus. So we got rigatoni, we got soba. When we tap rigatoni, he falls over and does his little action. Very cute, makes a little buzzing sound. And from every once in a while, they're just going to kind of chirp and blink. Soba's a little bit younger, so he's not quite as sure-footed. This is so fun just to look at and watch, though. And they'll be keeping me company here on my desk in future streams. I think that's about all I have for right now. I might actually come back with another stream a little bit later this evening or another robotics project. Not totally sure. But for right now, thank you all so much for watching. Thank you for being here to see the birthing of Soba and to hang out with me and Soba and Rigatoni. And make sure to subscribe to the channel, The Game of Knowing, for more streams. We're now doing this every Saturday, and hopefully we'll maybe be able to add a few more days over the course of the week. I just got this new second camera, so it makes it a little bit easier for me to do these. And then also for more updates and to see when I'm streaming, follow me on Twitter. That's Twitter/AllEternalsDeck, AllEternalsDeck, and leave a comment, like, subscribe if you want more content like this, or let me know what you do want. And I'll see you in the next one. Thank you so much. Bye. Bye again.